We're working with section 16.2, solving exponential equations. So in these problems, they're going to work a little differently. We're going to have to take the logarithm of both sides. Now, the only thing we really need to get from this page is if you want to solve these graphically, we're focusing again on algebraically, but if you want to solve them graphically, you'll solve them the same way we have been doing other problems graphically. You graph each side of the equation and then see where they intersect. So pretty straightforward thing to do there. Algebraically is what we're working towards here. So the key thing you want to do here is to isolate your exponent, isolate your base and the exponent, and then you can take either log or the natural log of both sides depending on what your base is. So here we're trying to get that e to the 4x by itself. So we'll have to divide by 5. And then since it is an e, we want to take the natural log of both sides. Taking the natural log of both sides is the undoing of e to the power, so it'll just leave us with the exponent of 4x. So now we have natural log of 2 is equal to 4x, divide by 4, and then you can just use your calculator to solve the problem. So a problem like this, we want to get that 5x by itself, so we need to add 4 to both sides. So we get that 5x is equal to 11. So now we want to take the common logarithm. We want to take a log of both sides. So log of 5 to the x would be equal to log of 11. Since we got that x in the exponent, we can bring it right on outside of our logarithm. So we'll get x log of 5 is equal to log 11. And then we just divide both sides by log 5. At this point, you can just grab your calculator, do log 11, divide by log 5. You end up with an answer of about 1.490. So if we have the equation 2 to the x minus 3 is equal to 85, how can we solve this using log base 2? It's the same idea. We're going to take log base 2 of both sides. It's like what we did when we took natural log, because that's log base e. If we take log base 2 of both sides, it's going to undo this 2 to the power. We'll just be left with the exponent. So we just be left with x minus 3 is equal to log base 2 of 85. So then we'd have to add the 3. Unfortunately, our calculator can't do log base 2, so we'd have to do the change of base in order to solve it. So we'd have log of 85 over log of 2 and then plus 3. You'd end up getting the same answer as if you did log base 10 of both sides. So we want to solve these equations. So again, first thing we want to do, we want to isolate the base and the exponent. So here we're going to subtract the 5. And then we're going to divide by 2. So now we're going to take the natural log of both sides since our base is e. So taking the natural log of both sides, we'll just be left with the exponent. And then we can just add 1. So x is going to be natural log of 37.5 plus 1, which is about 4.624 when you plug that into your calculator. So here we have 6 to the 3x. So our base and our exponent are already isolated. So we're going to take the log of both sides. So we're going to do log of 6 to the 3x is equal to log of 12. So then that 3x that's in the exponent, we can bring it outside. So we'll have 3x times log of 6 is equal to log of 12. Now we can divide by log 6. And then divide by 3. So instead, how I'm going to write it is I'm going to take this log 12 divided by log 6. And instead of writing divide by 3, I'm going to say multiply by 1/3. Same idea. And you'll get an answer of about 0.462. So if we want to solve real world problems, you'll often see stuff with decay and exponential decay and growth, as well as investments, because those are growth formulas as well. So here we have $250 is deposited into an account that pays 4.5% compounded quarterly. So the equation A equals P times 1 plus R over 4 to the N gives the amount A in the account after N quarters for an initial investment that earns at a rate R. So we want to solve for N, see how long it takes for the account to reach $500. So initial investment, $250. Interest rate is 4.5%. So as a decimal, it's 0.045. And then we want to see when that's equal to $500. So we're going to plug in all these values and then solve for N. So we'll say 500 is equal to 250. And then I already plugged this into my calculator, that 1 plus 0.045 divided by 4. It's going to get you a weird decimal. You always want to change it back into a fraction so you don't have to worry about any rounding errors. So into a fraction, it's 809 over 800, and then that's to the n. So divide by 250. And then you're going to take the natural log of both sides. So once you take the log of both sides, remember that n is an exponent. So I'm going to go ahead and bring it right out front right away. The exponents can come out front. And so then we can just divide. So n is going to be log 2 divided by log of that 809 divided by 800. And you get about 61.96. Now this is representing how many quarters it takes. So if you want to think about this in actual time, you divide that by 4. It'll be about 15.5 years for that value to reach $500. All right, so we've got how long will it take to triple a $250 investment into an account that pays 4.5% compounded quarterly? So I'm going to take that same formula they already gave me, plug in my pieces. Instead, I'm going to, in the exponent, I'm going to plug in a 4t instead, because that's what we're more typically used to, is to the nt power. We want to know our time in years. So if we're wanting our initial investment, $250 to triple, that would give us a value of 750 is equal to 250. I'm being lazy and all that mess. So divide by 250, we get 3. Is that 1 plus? Oh, we can rewrite this with that. Oh boy, it undid a lot of stuff. Sorry about that. Not very likely right now. Sorry. Where was I? Oh yeah. The 1 plus 0.045 divided by 4 we already found as a fraction was 809 divided by 800. So take that to the 4t. Now we take the log of both sides. Since that 4t is in the exponent, we can bring it right outside. And then divide. So that's equal to 4t. So then we'll need to divide by 4 or take that log division and multiply by 1/4. So you get about 24.6 years.